All right, so transformations of functions. So these are different types of graphs that we're writing down, and we should know what they look like now. So a constant function, the domain is negative infinity to infinity, the range is c, and this is an even function. What's like the equation or the formula for a constant function? Y equals, in this case, y equals c, right? Or we could call it b if we want to call this the y-intercept if we want to be consistent with what we did previously. Y equals b, it's a horizontal line, right? Okay? The identity, does anybody know what the identity is? It's obviously a line, but it's the line y equals x. So y equals mx plus b. This is a line with slope 1 and y-intercept 0, right? The domain is negative infinity to infinity. Same with the range, right? All possible x values, all possible y values. And this is an odd function. Can somebody remind me graphically what an odd function and what an even function are?
An odd function can reflect over both axes, like the x reflects over both, and either one reflects over the y.
Good. So an even function reflects over the y-axis. It's mirrored over. An odd function is reflected over the x and then over the y. So that's reflected about the origin. Okay? Good. The absolute value function, bless you. We've talked about the absolute value function a bunch of times, but I don't know if we've ever graphed it. So this is what the absolute value function looks like. And this is y equals the absolute value of x. So the domain is negative infinity to infinity. I have all possible x values, right? Domain is possible x values. And the range is 0 to infinity. The y values are always positive, right? Bless you. If I do the absolute value of any number, it comes back as positive, right? So that's why the range is negative, or is 0 to negative, or 0 to infinity. And this is an even function. It's reflected over the y-axis. Good? Okay, quadratic function. We've done stuff with quadratic functions, right? What makes something quadratic?
Square.
Good. It's degree 2. Bless you. A lot of sneezes going on here. It's allergy season. My husband's struggling. Okay, so quadratic function, this is y equals x squared. So we've done problems where we solved quadratic equations where we had ax squared plus bx plus c. But this we're going to call our base function. So this is y equals x squared. And the domain is my possible x values. That's all possible x values. And the range is possible y values. So this is 0 to infinity. And obviously it's even, right? So the square root function. So if I take the square root of this, usually I only take the positive, or else it's not a function, right? This over here looks like a line on your paper. Make sure it's not a line. That's not part of the graph. It just came out darker on the x-axis. So that's not part of the square root function. The square root function is here. So this is y equals the square root of x. You have domain and range. It's neither even nor odd. Then we have the cubic function. So this is like y equals x cubed. And then we have the cube root function, y equals the cube root of x, right? There's a little 3 in there. For the square root, there's an invisible 2. Or an implied 2, I should say. Okay, so these are all of our base functions. we need to know what the graphs of these functions look like. So I would recommend making flashcards if you're not comfortable with these things, right? Know what these functions look like. Because now we're going to take these functions, these basic functions, and we're going to move them around on the graph in order to easily graph them. Okay? So first we're going to talk about graph shifts. Vertical shifts and horizontal shifts. So vertical will be up and down, horizontal will be left and right, right? So how are we going to shift the graph vertically? Well, if we have a function f and a positive number c, y equals f of x plus c, so I'm adding some constant out on the outside, shifts f of x up c units. If I subtract on the outside, I shifted down c units. So I'm adding and subtracting on the outside of the function, and that moves it up and down. So I think outside is up and down. Okay, if I do a horizontal shift, given f of x and a positive number c, y equals f of x plus c. So here I'm adding and subtracting c on the inside of my function, right? And we did examples of f of x plus h, right? So here when we did f of x plus h, we actually had to go in and plug x plus h in for our x. That's how it's different, right? So this is inside the function. We add inside, that shifts left. So plus means left on the inside, plus on the outside means up. So got to remember it, right? So inside is right and left. But opposite, that would be intuitive, I think. Okay? So there's a lot that we need to remember in this section. So let's graph. So describe the following transformations on the graph. F of x equals x squared plus 3. Number 2, g of x equals x minus 4 cubed. So basically what we're doing is we're looking for one of these basic functions here. And then we're adding 3, and we need to figure out if that's a shift to the left, or shift to the right, shift up, or shift down. Okay? So what's our basic function here that we have? Yep, so our main function is x squared. It's our main function. This is what x squared looks like. Y equals x squared. Okay? So now I'm adding 3 here. So I'm adding 3 on the outside or on the inside of the function? On the outside, right? I'm just saying x squared, and then I'm tacking on plus 3. So I'm adding 3 outside, which means I'm going up 3. Okay? So I'm taking my graph, y equals x squared, that goes through the point 0, 0, and I'm going to shift that up 3. So that goes through 0, 3. What's another point on this y equals x squared? So here we have 0, 0, and here we have 1, 1, right? If I plug in x equals 1, I get y equals 1. So there's that point 1, 1. So I'm going to shift that point 1, 1 up to here. I'm just taking 1, 1 and moving it up 3, right? Okay, so that's the graph of that function. So similarly, g of x equals x minus 4 all cubed. What's my main function? Good. My main function is x cubed, right? So what's my shift doing? So x cubed looks like this, right? Am I adding or subtracting on the inside of x cubed or on the outside of x cubed? Inside. Is that clear? I think Blair gets it, right? This is, I'm adding on the outside This is, I'm actually plugging in x minus 4 into my function, into my cubic function, right? Do you guys see it or not? Yes? I can't tell if I need to do more examples or not. Raise your hand if you want more examples. Okay. So this is, I'm subtracting 4 on the inside. So that means I go to the right 4 units. So I'm going back to my cubic function. I have this point 0, 0, and I also have the point 1, 1. And I'm just going to shift those points to the right 4 units. So 0, 0 to the right 4 is here. 1, 1 to the right, 1, 2, 3, 4. I go here, and then I have this point. So that's what that would look like. Okay, so let's say we're not sure if we're, so let's say we have a function given h of x equals the cube root of x. Determine the function that one shifts h of x to the right, to the left, 2 units. Okay, so shifting to the left 2 units. Can I cover this up? You guys got this right here? Okay, so if I want to shift to the left 2 units, that's a horizontal shift, and I would have to go to the left 2 units. So I would have to do this, right? So this is what I'm looking at. I have h of x, and I want to shift h of x to the left 2 units. So c becomes the 2. So I actually need h of x plus 2. Shifts f of x to the left 2 units. So I'm just plugging in my c equals 2, and I'm putting it here. Now, whenever I compute h of anything, I go to my function h. Wherever I see an x, I put this. So that would become the cube root. Instead of x, it becomes x plus 2. So that's shifting to the left 2 units. Okay, if I wanted to shift h of x down 5 units, then what do? So I have my regular h of x, which is one of those functions from part A, and I want to shift it down 5 units. So which one am I doing? Which one shifts down? I feel like we need to do jumping jacks or something sometimes. Everybody's like a little asleep and quiet. The top, right? So down c units, I want to go down 5 units, so it needs to look like this. So I have h of x minus 5. Okay? So now I just need to write what h of x is and subtract 5 from it. Okay, so h of x is the cube root of x minus 5. So this I'm doing on the outside of the function. This is happening on the inside of one of these functions, right? So this is happening on the inside of the cube function. Or inside of the cube root function. This is happening on the outside of the cube root function. So that tells us if it's vertical or horizontal shift. If it's outside or inside the base function. Does that make sense? How many of you guys have done this before? Yeah, this is usually a harder section for people because I don't know if everybody's done it. Whereas like linear functions, everybody's done, right? But this stuff, you definitely need to review it, and if you haven't seen it before, you need to work for it. All right. So, continuing talking about transformations of functions, how we're going to take those functions from part A and move them around the graph. Here we can talk about reflections of the graph. Reflections about the x-axis. Given a function y equals f of x and a graph y equals negative f of x, that is reflected about the y-axis. Why is this kind of easy to remember? Why does this make sense? Oh, this is reflected about the x-axis. This is reflected about the y-axis. What do you think? What is this reflected about the x-axis or reflected about the y-axis? What did we say was reflected about the y-axis? Even functions, right? Even functions are reflected about the y-axis, and that was when f of x equaled f of negative x. So that kind of makes sense, right? This piece makes sense because it's like even functions. So reflected about the y-axis, that makes sense. Reflected about the x-axis, it's part of the odd definition for odd functions, but it's not exactly it, right? So for it to be reflected about the x-axis, the graph, if you put the negative in front, you take one of those basic functions and you reflect it over the x-axis. Here you reflect it over the y-axis. Okay, so now we need to see if we have negative x or if we have a negative times the function, right? So describe the following transformations of the graph. So f of x equals negative x squared. So what's my main function? Going back to that first page, part A, the main function is x squared, right? Y equals x squared. So this negative x squared, is that negative f of x or is that f of negative x?
Negative of x.
Which one is it?
The top one.
The top one? Why do you think that, Blair?
Because it's not on the inside.
Because it's not on the inside, right? So we're looking at, is this, so here, let's, if you're not sure, you can write them out, right? You can write out which one this is. So f of negative x, I go to my function f, which is this. Wherever I see an x, I put negative x. Remember when we did this with even functions? Negative x squared actually equals just x squared. So that's not the same, right? So this is not reflected over the y-axis. Oh, no, yeah. So this is not reflected over the y-axis, right? Now let's see this one. Negative f of x is, I put a negative out in front of my function. Those are the same, so this is reflected over the y-axis. Okay? So I'm going back to y equals f of x, and I'm taking, we already talked about 2 points that we knew, right? 0, 0, well 0, 0 reflected over the x-axis is just 0, 0, right? And then I had that point 1, 1. If I reflect 1, 1 over the x-axis, what is that point? Okay, so I have my toolbox function, which is y equals x squared. I'm reflecting points over the y-axis because this is the transformation of my function. So if I reflect the point 1, 1 over the x-axis,
-1, or 1, -1.
1, -1. So it goes from here, here's the x-axis, and I just reflect it over. So that becomes my function. Okay, number 4, g of x equals a square root of negative x. So is the negative on the inside of my main function or on the outside of my main function?
Inside.
So the main function is what? Y equals the square root of x, right? I'm going to the first page to section A and seeing what I have and what that looks like. Well, it looks like the square root of x. There's some plus or minus, addition, subtraction stuff going on, right? So now let's see if I have g of negative x or if I have negative g of x. Right? I want to see where that's reflected because that's what that negative does. That negative reflects. So let's do g of negative x. I go to my function g. Wherever I have an x, I put negative x. And that is what I have, right? So if you can see that, you don't have to write this part down. If you can see it, you don't have to write this part down, but this is a good way to check if you're unsure. Okay, so this negative x is on the inside, so that means I'm reflecting it over the y-axis. So we're going to go to our function from the first part here, and we're going to reflect it over the y-axis. Okay, so reflect it over the y-axis. Okay. So now let's do some stretching and shrinking. Vertical stretching and vertical shrinking. So vertical stretching and shrinking. So given a function f, which is one of our functions from part A, one of those main functions, and a positive number c, if c is greater than 1, then y equals c times f of x is a vertical stretch. So just think of it as taking those functions from part A and just pulling the ends. That's a vertical stretch. If 0 is less than c is less than 1, then the graph y equals c of x is vertically shrunk. So it's like a squishing. Horizontal stretching and shrinking. I have c on the inside. So if c is greater than 1, then it's horizontally shrunk. And if 0 is less than c is less than 1, then it's a horizontal stretch. Okay. So I tried to do examples of all 4 here. So I want you guys to go through and identify vertical stretch, vertical shrink, horizontal stretch, horizontal shrink based on how the function looks. First, identify the main function from the first page, and then determine if it's inside or outside the function, right? Am I multiplying a number times my function on the first page, or am I putting that number into the function? So at the bare minimum, you guys should all have down what your main function is from the first page, right? That's something you can easily identify. If you're a little confused about the other stuff, go through and do like we did on the last problem. See if you're multiplying something inside your base function or putting that thing on the outside of the base function. Okay, so what's the main function for number 5? Good. F of x equals x squared. What's the main function for number 6? F of x equals the square root of x. What's the main function for number 7? And square root of x. So these three have the same main function, right? So why don't we look at number 7 and number 8? So I have 1/2 times the square root of x, and number 8, I have the square root of 1/2 of x. So is 1/2 on the inside of f of x, or is it on the outside of f of x? Here it's on the outside, here it's on the inside, right? Right? So here I have the square root of 1/2 x, and here I have 1/2 square root of x. So this is inside, this is outside. So once I've identified that, I just need to go and look at the relationship, right? So this is on the inside, so here's my inside stuff, right? This f of cx. So now I need to...
What is 7 on the outside?
Oh, sorry. I wrote these backwards. So this is 1/2 square root x, and this is square root 1/2 x. So this is on the outside. This is on the inside. Okay, so if it's on the outside, I'm going to the outside section, right? This is 1/2 times my main function. And now I just need to look at the relationship. So is 1/2 greater than 1, or is it between 0 and 1? Between 0 and 1, so it's vertically shrinking. Okay, so I have that point 0, 0, right? I have that point 0, 0. How do I vertically shrink? Well, let's look at the square root function. So I have the point 1, 1 on my square root function. Is there another point on my square root function that might be easier to stretch by a unit of 1/2, or that might be easier to shrink by 1/2? Because that just takes the point, that point 1, 1 and shrinks it by 1/2, so it puts it right there, right? Which is kind of ugly to look at. Is there another point on this that you can think of? What about if x equals 4? What's the square root of 4? 2. So that would typically be a point on the square root function, but on 1/2 times the square root, it would be 1, right? So if some of this is confusing or a little tricky to remember, you can plug in points to make sure you're graphing it correctly, right? So it's vertically shrunk. I'm like squishing it down. Let's look at this. We said that this was inside. So inside, I'm going up here, and I have 1/2 falls in this category. That's horizontally stretched. Okay, so again, I have the point 0, 0. The point 0, 0 is not going to change. It's like I'm pulling it, stretching is like pulling away from the x-axis or squishing horizontally, or it's in relation to the y-axis or the x-axis, whether you're doing it horizontally or vertically. Okay, so who can help me with this? Tell me another point that's on here. All right, well, let's take that point. Let's say we choose x equals 2. If I plug in x equals 2 into this, what do I get? 1. X equals 2, y equals 1. What if I plug in the point 8? X equals 8. What do I get? 8 over 2 is 4. The square root of 4 is 2. So over 8 up 2. So sometimes people feel like these are the same, like these are very similar, vertical shrinking and horizontal stretching, but they're not, right? We have completely different points on these graphs. All right, should we do 5 and 6? Yeah? Okay. So we said our main function here is x squared. That 2x squared, am I multiplying my function by 2, or am I putting 2 into the x squared function? I'm multiplying everything by 2, right? On the outside. Because on the inside, it would look like 2x squared. That's inside. This is on the outside. This would be like I was putting 2 into the function. This is like I'm just multiplying the entire thing by 2. So that's a vertical stretching or shrinking. 2 is greater than 1, so it's the first one. So it's vertically stretched by 2 units. So again, for y equals x squared, 0, 0 is a point. What's another point? So if I'm vertically stretching by 2 units, the point 1, 1 goes to what? 2, over 1 up 2, right? If I can't remember, I can plug in a point, right? If x equals 1, 1 squared is 1, 2 times 1 is 2. That tells me a point. What if x equals 2? What's my point? 8. So I have over 2 up 8. So I'm taking those regular points on x squared and I'm pulling the ends, right? Away from the x-axis. That's why 0, 0 stays there. Do you guys think you can do number 6 by yourself? If you didn't already do number 6, do it, right? If you can express what is written in pink, that's really important, but then you can also mentally plug in points in order to make it happen, right? So the 2 is on the inside, right? 2 is on the inside of the square root function. 2 is greater than 0, so it's horizontally shrunk. Okay, so let's see what that looks like. 0, 0, because it's a point on the square root of x, it's going to stay a point on the square root of x, right? And then I'm going to horizontally shrink it. So let's come up with some points if I can't remember. What's a good point to look at? What's a good x value for this? If I do x equals 1, I have the square root of 2. Can you graph the square root of 2? I don't know. Ugly, right? What if x equals 2? 2 times 2 is 4. The square root of 4 is 2, right? So I have this point 2, 2. What's another good x value? If x equals 3, I have the square. 3 times 2 is 6. The square root of 6, I don't know what that is. 8? If I put 8 in, x equals 8. 2 times 8 is 16. The square root of 16 is, good, so I have the point over 8 up 4. So this is like I'm squishing it. Horizontally shrunk. Okay, good. Okay, now we get to the tricky part. So the tricky part is putting all of those ideas together. Horizontally stretching and shrinking, reflecting, moving up, moving down. So we're putting all of those ideas together. So the sequence of transformations. So first, this is the order. First we have horizontal shifting. What does horizontal shifting look like? That looks like f of x plus or minus c. So on the inside of my main function, I'm adding or subtracting. That's a horizontal shift. Stretching or shrinking is what? Multiplying by a number, right? So I'm somehow multiplying x by a number, whether it's outside the function or inside the function. Okay, then I'm reflecting. What does that look like? X is somehow going to be negative, right? X is somehow going to be negative, whether it's a negative outside the main function or whether it's a negative right on x. In a vertical shifting, what does that look like? F of x, adding or subtracting a number on the outside of my main function. So first we need to identify the main function we're dealing with, and then we're going to look at those different things. Okay? What? A negative. Reflecting is like a negative on the x, right? Either I have negative x or I have f of negative x or I have negative f of x. Okay, so describe the following transformations of the function of the graph provided. So I have f of x equals 2 times x minus 1 squared. So what's my main function? Main function is y equals x squared, right? Sometimes I write function as FCN. Main function is y equals x squared. So first I'm going to look for horizontal shifting. Am I adding or subtracting something inside of the x squared function? So here I have x, and then I'm saying minus 1 on the inside of my function. And what does that do? Does it shift it left or shift it right? Go back to the first or second page and look. Right 1 unit. Okay. So I'm going to try to color code this as much as possible. Okay, so no, I'll just draw the end graph. Okay, So then second, I'm looking at stretching or shrinking. Am I multiplying by a number? Am I taking this and multiplying it by a number? Yep, 2. So 2, there I have 2 times x minus 1 squared. And what does that do? Vertical stretch. Two units. Okay, and now you can see that's my function, right? So I don't have any reflecting and I don't have any vertical shifting. Okay, so let's try to graph this. So I have a point 0, 0, right? I know what x squared equals. I have the point 0, 0. I'm shifting it to the right 1 unit, and then I'm stretching it. But again, we don't stretch vertically away from the x-axis. So that's that point right there. Vertical stretching 2 units. We did it on the last page, right? We said that if I had this point 1, 1 on my regular graph, it went up by a multiple of 2, right? So let's do that. So that's how it should look. So that's the graph. So notice I'm showing at least 2 points on my graph, right? Just to verify that it's correct. But I'm also describing what happens to it. All right, let's do this one. So what's my main function in number 10? Main function is the square root of x. Y equals the square root of x. If you're not sure, go back to the first page. What does this look like? Not cube root, not cube, not squared, not the absolute value, right? Okay, the main function is the square root of x. Am I adding or subtracting inside of the square root function? Okay, so I have x minus 5 under the square root. What does that do? If you're not sure, go back here, right? Shifts it to the right 5 units. I'm subtracting inside, that shifts it to the right 5 units. All right, 2, am I multiplying it by a number? Do I either have a number in front of x or a number in front of the square root? No. 3, do I have a negative? Negative on x or negative on the square root? No. What about 4? So I have the square root of x minus 5, and then I have plus 2 on the outside, right? The adding or subtracting on the outside moves it up or down. And what did you say, Blair? That's up 2 units. Okay, so I'm going to take that point, the square root, right? The square root function looks like this. I'm going to take the point 0, 0 and move it around like we just talked about, right? And then I'm going to take the point 1, 1 and move it around like we just talked about, and then draw this kind of shape. Okay, so let's take the point 0, 0. I need to move it to the right 5 units. That goes here. Then I need to move it up 2 units. That goes here. So that becomes my point. Now I'm going to take the point 1, 1 and do the exact same thing. 1, 1 to the right 5 units and up 2 units. And then I'm going to draw that arc. Okay? All right, y'all. We'll finish this next time. I'll make sure that the homework is available so you guys can do it. And we'll make it do